In this video, we are going to talk about some angle vocabulary, and we'll do a little bit of algebra practice. So, angles like angle 1 and angle 2 are definitely going to be supplementary. Now, remember that supplementary means adding up to 180 adds to 180 degrees. Now, whenever you see a straight line like this, see how angle 1 and angle 2 form a straight line. A straight line is always going to give you 180 degrees. You can picture a semicircle sitting on top of that line, and that would be 180 degrees. So watch for the straight lines, and they're going to be supplementary. Also, when angles form a straight line like this, they are called a linear pair of angles. All right, so this is a linear pair. Now, the word adjacent means that the angles are sharing a side. You know, they're side by side touching. And so a linear pair is also going to be adjacent. All right, are they congruent? No, they add up to 180, but they don't have to be the same. This one's acute, this one is obtuse, less than 90, more than 90, so they're not congruent. Complementary means that they add up to 90 degrees, so they're not complementary. And they're not vertical angles either. Vertical angles are angles like this angle and this angle. Okay, moving on to problem number 2. Angles 1 and 3. Well, these angles are complementary. Let me jump to that first. All right, complementary means that they add up to 90 degrees. So adds to 90 degrees. You can see that this angle right here is 90 degrees. But that means that this angle over here is also 90 degrees. So angle 1 and angle 3 are sitting nestled inside of a 90 degree angle. So you know that they are going to add up to 90. They are going to be complementary. They do not have to be congruent. All right, angle 1 looks smaller than angle 3. They are not supplementary. They are complementary. They are still adjacent angles. Remember, adjacent means that they are side by side. They're sharing a side. They're touching. They are not a linear pair because they don't make a straight line. They are not vertical angles. So it's just these two. All right, let's move on to number 3. All right, angles like 1 and 4. Now these are vertical angles. All right, vertical angles are what you get in general when you have lines that are intersecting. You're going to have 2 pairs of vertical angles. So, for example, this angle, these green angles are vertical angles, and vertical angles are always going to be congruent. But also, these angles are vertical angles, this pair. Okay, and that's what you have here. So angle 4 and angle 1 are vertical angles, so they will be congruent. They're not complementary, they're not supplementary. They're not adjacent, right? They're not side by side. They're not a linear pair, so it's just these 2 things. All right, moving on. So given that angle A is 40 degrees and angle B is 50 degrees, all right, well, that tells me that the angles are complementary. All right, because 40 plus 50 equals 90. So these add up to 90 degrees, and that's what complementary means. They're not congruent because they're not the same. If they were supplementary, they would add up to 180. Okay, so here we have 80 and 100. Okay, so obviously 80 plus 100 is 180. That makes these supplementary angles because they add up to 180. They're not congruent. They're not complementary. Okay, what about number 6? 45 and 45. Okay, well, 45 plus 45 is 90. So that means that they are complementary. All right, but they are also congruent because they are the same. All right, moving on to number 7. Find all missing angle measures. Mark your answers on the diagram. So when you see the X, you know you've got vertical angles. So I see the 65 degrees over there. That's going to match the 65 degrees over here as well. But then we've got the linear pairs to think about. So for example, look at this linear pair up here. In fact, maybe it would be better if I put 2 different colors. So look at this yellow angle and this blue angle. Okay, this is a linear pair. Together they make a straight line. They are going to be supplementary. So they have to add up to 180. So let's subtract 65 from 180. So that is 115. All right, but then we've got vertical angles going on right here. So this is also 115 degrees. All right, the swoops, man. See, we've got this mark right here and this mark right here. That means that these angles are congruent. So this must be 40 degrees. Now, clearly this is a linear pair. So these have to add up to 180. So this must be 140 because that adds up to 180. Now, in this picture, we have some vertical angles here and here. So I definitely know that this angle right here is going to be 30. Okay, now this next one is a little bit tricky. So you see this 90-degree angle right here. So this yellow angle right here is 90 degrees. All right, now that means that this blue angle has to also be 90 degrees. All right, because of the way they are back to back. All right, if this one is 90, you know, if this either this line is perpendicular or not. So if it's 90 on one side, it has to be 90 degrees on the other side. But that gives me additional information, doesn't it? If this blue angle is 90, that means this portion right here must be 90 minus 30. All right, this angle right here must be 60. All right, because it has to add up to be 90. All right, so that's it. Obviously, this one already has the box, so I don't think we really need to put 90, but hey, there you go. Oh, you know what? I think we're supposed to say this other angle out here too. Let's go ahead and look at that. I think I want to use my yellow and blue trick again. Okay, so look at this yellow angle. And then look at this blue angle. All right, how are they going to be related? Can you see that they are a linear pair? See how together they make a straight line? All right, these straight lines are your best friend. So that means that they have to be supplementary. So if I want to find the blue angle, I can just subtract from 180. All right, so this is going to be 150 degrees. Okay. All right, so that was it for the angle vocabulary. Now, let's practice our algebra skills. So if you want to solve an equation like this, we're trying to get x by itself. So we need to subtract 18 from both sides first. So that will give us 2x is equal to, so we can just go 46 minus 18, and that's 28. And then we divide by 2. And that's how you get x by itself. So you end up with x is equal to 14. Okay, so number 11. When I see the variable on both sides of the equation, the first thing I want to do is get those together on one side. So I will subtract 5x from both sides as my very first step. Combining these like terms will give me negative 3x. And I just bring down the rest. Plus 18 is equal to negative 6. So now we're trying to get x by itself. So we have to subtract 18 from both sides. Okay, we have a negative and a negative. So we're just going to add these up, and it'll just be a bigger negative. So negative 6 plus negative 18 is negative 24. Okay, if you really had to do this on a calculator, it'd be negative 6 minus 18. All right, but hopefully you don't need a calculator for that. And then the last step is to divide both sides by negative 3. That gets x by itself, and x is equal to positive 8. Okay, how about number 12? Interesting. So I see that we have like terms here. Notice that these are on the same side of the equation. So we're just combining like terms. A common mistake I see is sometimes students will try to subtract this like we do remember when we subtracted 18 from both sides? Students will try to do something like that here. But these are on the same side of the equation, so you just combine like terms. Okay, so if I add these, 18 plus 46, that's going to be 64. So I have 2x plus 64 is equal to 90. Now subtract 64 from both sides. We'll have 2x equals 26. And then we just divide both sides by 2. All right, now looking at number 13. Again, we have like terms on one side of the equation. So we need to combine like terms before we do anything else. So the 2x and the 5x are like terms. And the 18 and the -6 are like terms. So 2x and 5x, that makes 7x. 18 minus 6 is 12. And that equals 90. Whoops, 90. Time to subtract 12 from both sides. Okay, so that's going to be 78. And then it's time to divide by 7 on both sides. Okay, so that's a decimal. Are we allowed to have decimals? 11.143. Got to round up. All right, so if we're looking for a decimal, does it say round answers to 3 decimal places if necessary? Okay, so there you go. Let me show that last little step there. All right, so that is it for number 13. Okay, these last couple problems have parentheses in them. We are undaunted. You remember that when you have a number and then parentheses, you're going to do the distributive property. So 2 times 2x will be 4x, and then 2 times 18 is 36. Now, I see that we have variables on both sides of the equation. So I need to get them together. So let's subtract 5x from both sides. That's going to give us -1x. All right, we don't really need the 1, but I'm just going to leave it there for now. Plus 36 is equal to -6. Now we will subtract 36 from both sides. So that gives us -1x is equal to -42. Now, finally, we will divide both sides by -1. All right, that's kind of why I left the -1 there, to make it more obvious what we are doing. So that will give us x is equal to 42. All right, last one, again, the distributive property. So 2 times 5x is going to be 10x. 2 times -6 will be -12. So we have the variable on both sides. So whenever you see that, you should subtract one of them so you can get them together. So that's going to make 8x right here. Bring down your -12, and that equals 18. Next, we will add 12 to both sides as we try to get x by itself. So that's 8x is equal to 30. So this will be a decimal because we know that 8 does not go into 30 evenly. So we divide both sides by 8. All right, 30 divided by 8 then. That is 3.75. All right, that's it for this video.